We're asked to write the given expressions in lowest terms. So what it's a matter of doing is reducing. So we're going to take a look first at number 4 here. 25k squared over 8k. Well, can I reduce 25 and 8? 25, the only factors of it are 1, 25, and of course 5. 8, we've got 1, 2, 4, and 8. So no, we can't reduce these two numbers here, but I think we can do something with this. Now, I'm going to show you a trick. What you can do is write it out as 25 times k over 8k. Now, some people like to write it out like this, and that's okay, but you have to deal with the issue of, well, what if you have, larger numbers in your exponents, So it makes it a little bit tedious. So what you need to do is you do this, and you can cross out these k values, because I have 1 on the top and 1 on the bottom, and I line them out. Why do I say line out and not cancel? Because when it lines out, you are left with a factor of 1 and not 0, because that's what is implied when you say the word cancel. So in this case, this answer right here is actually fully reduced. We can't reduce it anymore. We can't write it in any more lower terms than it already is. So my answer is simply 25k over 8. Now I want you to recognize that all I did really was subtract. The power on top in the numerator was 2, and the one on the bottom in the denominator was 1. 2 minus 1 is 1. And notice that I am left with 1 in the numerator. Now let's take a look at the next example. So I have 5x plus 20 and 9x plus 36. Well, I'm going to look first at the numerator and see, well, can I factor out a greatest common factor, a GCF? So let's look again at the numerator right here, 5x plus 20. And I'm going to notice, well, 5 goes into 5 and 5 goes into 20. So let's write out a 5 here. So 5. If I were to multiply back in, 5 times what would give me 5x? Well, an x by itself. And 5 times what will give me 20? Well, that's simple. 5 times 4 is 20. So I factored out my GCF in this case, which is 5. Okay, so now let's go ahead and look at the denominator. Okay, I've got 9x plus 36. So let's think about this. 9 goes into 9 one time, and 9 goes into 36 4 times. So, okay, I'm going to factor out a 9 here, my GCF. Alright, so 9 times what gives me 9x? Well, simply x by itself. And 9 times what gives me 36? Well, 4. So x plus 4. There we go. There are my factors. I factored out the GCF. Now I want you to notice something. I've got 5 times x plus 4, and then in the denominator 9 times x plus 4. Well, notice these two things are exactly the same. And because we are multiplying, I can say that they will line out. So what I am going to do here is I'm going to line out my two factors that are identical. I have one on top and one on bottom. Again, it does not cancel. And that's a bad habit that you should be broken from. A lot of teachers mistakenly say that it cancels. Cancel implies you're left with 0. In this case, you're left with a factor of 1. So I say it lines out. So what we're really left with here is our answer, 5/9. So that's the answer for that question right there. Now if you look at something like number 6, which is a really nice problem, it's a fairly simple trinomials that you need to factor. So what we're going to do is we're going to take a look. Well, I've got m squared plus 10m plus 25. And then I've got m squared plus 9m plus 20. Well, I'm going to factor the top first, and then I'll worry about the bottom. Now, we're looking in this case for the factors of 25, such that when added, we get 10. Well, the only numbers that come to mind to me are 5 and 5. I know that 5 times 5 is 25, and I know that 5 plus 5 is 10. So I'm going to write this out as such. M plus 5 times m plus 5. So here are my factors. Notice again, 5 times 5 is 25. Okay, so 5 and 5 is 25, but 5 plus 5 is this 10 here in the center. So that is factored there. Now let's take a look at the denominator. I want the factors of 20 such that when added give me 9. Well, I know that 4 times 5 is 20, and 4 plus 5 is 9, so that should work. M plus 4 times m plus 5. Now let's take a look again. 4 times 5 is 20, 4 plus 5 is 9. Okay, great. Now we're going to proceed to eliminate any factors that appear in the numerator and denominator at the same time. Well, I've got m plus 5 over m plus 4 times m plus 5. Okay, now the question always comes up. Which do I eliminate? This one, this one, this one, or all of them? Well, what you're going to do is you're going to match one with another. So it really doesn't matter in the numerator. So I'm going to cross out this second one, and then I'm going to match it up with the one right underneath it. So I've eliminated these two. I've crossed them out. Okay, again, we're left with a factor of 1. So in this case, I'm ready to give my answer because it is simply m plus 5 over m plus 4. Now, I will tell you that a lot of people think they can eliminate or line out these m's, but the fact of the matter is that because we are adding in the numerator and adding in the denominator, we say m plus 5 and m plus 4, we cannot cross this out. We cannot line this out. Had it been multiplication, on the other hand, in both cases in the numerator and denominator, then we could have proceeded to cross out the m's, but that is not the case in this situation. So our answer is right here, m plus 5 divided by m plus 4. So that's what we're talking about when we want you to write an expression in its lowest terms.